Welcome to the Advancing Cyber Podcast Origin Story Series. For this series, I wanted to capture the origin stories from those who were there and involved at the beginning of cybersecurity, living it and helping to build the technologies, laws, and policies that we all know today. For many of the subjects we meet, these folks began working in security on or just before 9/11. However, for today's guest, we get to talk to someone who's now in his 55th year of cybersecurity, 55 years of cyber. He's one of my favorite people that I've ever worked with and has been involved in so many of our software assurance and security milestones that if you don't know his name yet, you've certainly benefited from his work. Today's guest is the one and only Steve Lipner. This bio that I'm about to share does not do Steve justice. Steve is the executive director of SAFECode, an industry nonprofit focused on software security assurance. He was previously partner director of software security at Microsoft, where he was the creator and longtime leader of the Security Development Lifecycle, or the SDL, if you've heard that acronym. He serves as the chair of the U.S. government's Information Security and Privacy Advisory Board, ISPAB, and has more than a half century of experience in cybersecurity as a researcher, engineer, and development manager. He's a member of the National Academy of Engineering. Wow, Steve, I'm thrilled to have you here because I met you in 2006 when we began working together in Microsoft. So we're coming up on 20 years. And that's amazing just to think about unto itself. But the fact that I've known and worked with you for 20 years and you already had 35 years of incredible history, that's amazing, right? Because so much of cybersecurity really did start around 9/11. And you're like, no way, let's go way back. And that's where I wanted to start because you graduated from MIT in the late 60s and then went to work for MITRE and started to work in the early days of cybersecurity. So this is pre-personal computing, pre-internet, pre-anything that we think about in modern cybersecurity today. So what was cybersecurity for young people coming out of college at that time?
So first, thank you, Cristin. It's great to see you and great to be here. It'll be fun to think about some of these sort of historical or older things that I've been involved with. Cybersecurity really sort of wasn't a consideration for most people, most computer users, most computer system managers back in the late 60s, early 70s. It just wasn't something they particularly thought of. You locked up your machine room. I remember going to a workshop in California, probably in 73, when there were supposedly a computer security workshop. And the guy there from IBM talked at length about their response to a fire in one of their data centers back a couple of years before that. And so, it was really physical security, lock the machines up. Maybe for businesses, you built application controls on the premise that your insiders were the threat to steal from you and your bogus transactions and steal money. And so you wanted enough control to limit them and audit them. That was about it in the private sector, the commercial world. The government had classified information, and for the government, the rules were lock the systems up and use approved encryption if you have to communicate between them. All the systems back then, mainframes, early days of time sharing, and at MITRE, we got presented a couple of our Air Force sponsors about how do we do multi-level security? How do we take classified information of different levels and process it on systems where not all the users are cleared or authorized for that level of classified information. And
Is
so
that
was the
because
problem
in a
we faced.
mainframe system, you would have had different people all working on the same system, feeding in punch cards and making it do things? And
Yeah. By the early 70s, you had interactive systems, where people could enter financial transactions or reserve airline tickets or whatever with remote terminals. And what I think of as actual time-sharing systems where people could log in and then write programs, share data on the system, and do work together. And so, some of those kinds of scenarios got overlaid with the considerations of multi-level security.
How does that come about for DoD? Is that the beginning of security policy? When we hear about the things that governments care about from a security policy perspective today, it's a pretty robust conversation. Was that really some of the early stages of government expressing what it cares about?
Mostly the rules were don't do that. Lock it up, make everybody have a clearance, use authorized crypto, and things will be fine. There's still an insider threat, but that's a personnel security problem. And no technical policy at all, except about things like how you installed the crypto and what kind of vault you used. So that was sort of the baseline. Then some of our Air Force had what at the time were sort of niche requirements. I have a mostly unclassified, but I want people to be able to do classified work with access to that data from that unclassified environment. Or I have a combination of a secret programming environment with a top secret data where I want people to be able to use the programs that the secret cleared programmers produce, but process top secret data.
That's pretty innovative coming from a real model shift. It's a model shift. It's a mindset change. What did you have to do differently? Or, were you already doing some of the same things we do today around looking for vulnerabilities and looking for pen tests and risk management? What did risk management look like to you as you were designing a truly innovative approach to security then?
One of the old stories was there was an aerospace contractor that had a big mainframe system that they used for their design calculations. And they wanted read out time on that mainframe just to pay for it. And so they wanted to let unclassified applications run on the mainframe in a multi-programming environment along with their classified aircraft design workloads. And so they configured the system as securely as they could, just an ordinary multi-program mainframe. And then they asked the Air Force, can we do this? Because the Air Force is classified data. The Air Force said, well, I don't know. And so they brought in a team from, I think DARPA was involved, but they brought in a team with some people from RAND and a couple of consultants. And they were immediately able to, defeat the controls in the mainframe and get access to classified information from unclassified terminal. And so that told folks that something was wrong. The aerospace contractor said, we'll fix that bug. Now it's better, try it again. And the penetration team came back and said, no, beat it another way and beat it another way. And after a while, the aerospace contractor gave up and just said, okay, we won't do that. So that was sort of the on-the-ground origin story. There's also something called the WARE report, which was a Defense Science Board report the effort was chaired by a guy named Willis Ware, who was my first predecessor as chairman of the ISPAB. And that they looked at the whole problem, including physical security, including software, including communications. And one of the things they concluded was that trying to do multi-level security with unclassified users was just a bad idea. Probably couldn't do it yet.
Wow. And yet, nevertheless.
And yet the Air Force had that requirement. So we tried. Mm-hmm. And we started looking, what would it mean to be able to do that? And one of the first things we did was to ask a couple of the mathematicians on the staff at MITRE to look and say, okay, from a sort of a formal sense or an analytic sense, what would it mean to have that capability? And that was the creation of the Bell-LaPadula model, Dake Bell and Len LaPadula, and the notion, what it called the star property, which was a formal requirement for not letting classified information get downgraded or declassified.
And that was a game changer.
was a game changer for a game people don't play anymore. But it had a huge impact because then, okay, we've got this model. How do we build systems that implement that model? How do we get enough confidence, enough assurance that the implementation of that model is something we can trust? And
So
and
that's the
that
A word, assurance.
those things, that led to the concept due to an Air Force officer with a PhD from MIT named Roger Shell, the concept of a security kernel. Basically, it's hard to write software, so if you can minimize the amount of it, that will at least cut down on the amount that you have to get right or verify. And so, then everybody wanted to build security kernels that implemented the Bell-LaPadula model. And that kind of took the cybersecurity industry, or a lot of vendor resources, down 15, 18-year rat hole.
That's a long time.
Including me.
That's a very long time. And so as you look back at that 15 to 18-year path, I would assume, based on the OSs we all use today, that you decided that that was not possible.
Well, we did a lot of development. We added, the Bell-LaPadula model to the access controls for some systems. A lot of companies did that in one way or the other. Honeywell Multics was sort of the one that we did a lot of our research on. But, there's an IBM mainframe package that did that. There was a DEC version of the VMS operating system that did that. I think Bell Labs did a lot of work on Unix, trusted Solaris. But and there were some niche applications of those systems. Mostly people, even government users, didn't really use them or didn't use the controls.
Because they were too hard, too complex?
It made the system not usable. It's a lot of management overhead. And, they certainly, there were certainly instances of applications that used them, but just not a lot. Very, very specialized, very limited. And meanwhile, the commercial market for computing was exploding. The government market for computing was exploding. Things weren't standing still. And the other thing is, we haven't talked really about the evaluation or certification, but that was a big deal.
So let's go there, because with the explosion of business applications and computing coming into industry and into government, I know that the government started to develop the software assurance Bible, the Orange Book, in 1983. Can you talk about what that was and what that meant from a security perspective?
In the 70s, when we were doing research at MITRE, we were sort of assuming government programs, government contracts. The government would pay somebody to build a secure operating system, and then they'd use it. And a guy at OSD, previously DARPA, previously NSA, named Steve Walker, led a batch of workshops with industry and researchers. And he concluded that it didn't make sense to have the government try to contract for its own computer operating systems. So what the government would do was to publish criteria, and then vendors would meet those criteria. Government would provide an evaluation. And if you pass the evaluation, then that would essentially license you to sell for classes of applications. And so the Orange Book was the formalization of that. And it had 6 levels of certification, of which the top 4 were based on multi-level security in the Bell-LaPadula model. Okay. And so the idea really was to recognize industry and also to kind of incentivize industry to do the things that DoD thought it needed. And so there was something called the National Computer Security Center, which published the Orange Book, published a batch of other guidance documents. They all had different colored covers called the Rainbow Series. And the NCSC also ran the evaluation process with technical people from NSA and from the nonprofit federal contractors, MITRE, Aerospace, IDA, and some consultants. And so the evaluation levels in the Orange Book ranged from essentially a commercial system with ordinary access controls that you'd recognize today from Windows or Linux or Android or iOS, up to systems that not only had the Bell LaPadula model built in, minimized software kernels that centralized the security controls, and a pretty high degree of formal verification as we understood it back in the 80s.
How long was the Orange Book and that NCSC process, like the focal point for assurance? How long did that last until it just, I guess, the world got too big to handle that?
So two things. At the lower levels of the Orange Book, the, C2, sort of commercial level controls, that lasted. And getting ahead of myself, the Orange Book sort of morphed into an international criteria called the Common Criteria, which is mutually recognized across a batch of countries. And that lives on today. The multi-level security aspect of the Orange Book basically lasted from before the publication of the Orange Book, the late 70s, early 80s, until probably the mid-90s, 92, 93, 94, by which time all of us in industry had concluded that the market just didn't justify going to those heroic efforts. There were still some outliers that lasted through the rest of the 20th century, but I think pretty much gone by the end of the 90s.
Wow. Okay. So the top levels, the A1 of the Orange Book doesn't exist anymore, but the lower levels of that would be, you said Common Criteria, that's also an ISO standard. I think it's 15408, if I remember correctly.
Right.
And so that's where assurance lives broadly. Can you talk a little bit about what that is? I know that you may not be there in it now, but I know you were deeply involved in it for a long time.
The common criteria. So the Orange Book, we did in the 80s, I think we probably didn't understand how easy it was to write vulnerable software. Okay.
We know it now.
Right. And so the Orange Book focused heavily on security features, access control lists, passwords, audit trails, the mandatory Security Development Lifecycle model, if you were going up to the higher levels. And it said, well, you'll specify all these things and you'll apply them to all the objects in the system managers, and you'll write the code and you'll get it right. And it was pretty heavily testing focused, although there was some elements of mathematical verification at the highest two levels. But there was no realization of how pervasive security holes in software were. And so, it was particularly at the C2 level, which was sort of the commercial standard, it was assumed that you'd get the features right, testing would get rid of the bugs, and it would be good enough unless somebody really tried hard to find a hole. And the other thing is that, I'm not sure I can trace the why of this, but it was very documentation focused. Write a user spec, write a programmer's manual, write a description of all the objects and how you applied controls to all of them. Great for the security features, important stuff, mostly not the way people attack systems. The Orange Book evaluation process had a lot of that. Common Criteria inherited it back in the, as recently as, as recently as 15 years ago. There was a debate between the US and UK Common Criteria member agencies and a batch of other countries about whether, all the assurance, by which they meant more documentation, really did anything for the security of systems of the Common Criteria. And the US basically said, we're going to go with a lighter weight process that recognizes that, you've got to have the features, they've got to be there, you've got to document that they're there. But all this sort of secondary documentation really isn't adding value. When I say I've been out of it, I don't know what the international consensus is. One other thing, the Orange Book still does go all the way up to evaluation assurance levels 6 and 7. Those are levels that are sort of the successors of the high levels of the Orange Book. They have formal verification requirements, Some companies do niche systems, especially for embedded applications that get to those levels. Haven't been involved with them, don't know how much, what the market.
Sure. The thing I always found fascinating about the evolution of the Orange Book, and the EU had some of its own in the space, and if I remember correctly, Canada did too, is that it's the same problem that we still have today, which is that when you have governments making their own slightly different requests, having the international standard is always preferable. And
Yeah.
so is that right? Is that what was driving the move towards common criteria?
Well, yeah. So, my recollection is that the Orange Book, the NCC process, was only open to U.S. vendors. Okay. And so in response to that, then a batch of other countries said, well, we're going to have our own too, and you're going to have to certify here. And that wasn't fun for the vendors, and, cost extra money, took every extra time, et cetera. And so there was, a lot of pressure to do something that would provide international mutual recognition. And that was what the common criteria was. I think there was a workshop probably in Brussels, probably in 1991, that sort of started that process. And the common criteria finally came out in 99.
That's amazing to think that common criteria is 25, 26 years old.
It's an agreement among a batch of governments. So, maybe it's not surprising. It took 7 or 8 years to get created and agreed to.
So one of the other things that blows my mind in looking back at your journey is that you were also involved in some of the early incident response issues in your DEC time. I mean, very different from what we have today, but I'm curious, what's that like when you get a phone call and you realize that there's an issue and you've got to go unpack what happened?
I was not part of the, sort of the forensic team that did all that, although those were not, sort of sophisticated technical attacks like we see today, very much social engineering. There was the Wiley hacker incident that didn't hit us. If I remember right, it didn't hit, or I don't recall it hitting DEC VMS systems. When DEC was attacked, a guy got onto the network. He was really expert at social engineering, calling people, asking for passwords, I'm locked out, what have you. And then the internal controls and partitioning weren't good enough, so he could just romp all over our internal network. And he actually I nearly killed somebody. He got into the development system for the A1 operating system that we were building. And so we had to do a full audit, basically, have the authors go back and look at all the source code of everything we'd written to make sure that nothing had been modified there. And then as part of that, I was asked, because they thought, well, you guys know about security. I was asked, okay, what should we be doing? And what we should be doing included, an early version of a firewall for the DECnet protocol. And it included an automated scanning tool to make sure that it included configuration rules for VMS systems, and it included an automated scanning tool for VMS systems to make sure that they were locked down appropriately. And so that was sort of an internal initial education. And then we made some of those available to customers, either, releasing through the DEC users group or in some cases as products. So it was really, a very early exploration of some of the things that are important today. I wouldn't say it was, sort of at the level of sophistication or pervasiveness that we see today.
And yet we are falling victim to social engineering and elevated privilege access. So it is not very different from an attack we could see today.
I don't know that there's anything, sort of in the internal configuration policies and stuff that we did back in that had been 1987, 1988. I don't know if there's anything there that we'd find irrelevant today. And I don't know that there's very much today that that's new.
Shocking on a lot of levels.
Yeah.
So then you came to Microsoft in the late 90s.
Right.
What brought you to Microsoft? What was the change and challenge that decided to bring you out to Seattle?
So I was working at that time for a nonprofit government contractor, spinoff of MITRE called MITRE Tech. I was running a division that included common criteria evaluation and some work on cybersecurity research policy for the government. It really wasn't super interesting, and it really wasn't super fun. And I had a friend who I'd worked with at DEC, who was at Microsoft, and he said, you really ought to be, coming out here. So I said, well, okay, I'll come out and interview. And I interviewed mostly with the engineering groups, but I was pretty senior at the time, and they didn't have a management position open. They had just filled a management position that I might have been a candidate for. And so they said, the process a little more involved with that, but doesn't matter. They said, well, we've got this thing called the Security Response Center, and it deals with externally discovered vulnerabilities in Microsoft products. How would you like to, and we've got a manager position running that. How would you like to lead the Microsoft Security Response Center? And I said, well, it sounds interesting. It's not going to be boring like what I've been doing. And I'll get to work with smarter people. And Microsoft is a, really good company. So that sounds like fun. And so I gave my notice and moved to Seattle and started issuing security bulletins.
Boy, did you. Wow. You hit at an incredible time. I mean, that's a really interesting time to come into the space.
I had about a year from fall of 99 to the fall of 2000, early 2001, to sort of get accustomed to the company and what the culture was like and how the engineering groups were, what the challenges were of getting security problems fixed. And then in the summer of 2001, of course, we started to have incidents where people exploited some of these vulnerabilities that we had been fixing. And that really changed things from the standpoint, A, of what the response process had to do. It took us a couple of years to fix that. And B, it upped the pressure on us to do a better job of security.
The world saw some of the big worms and attacks that were happening in that era. And the whole world knew about Bill Gates's 2002 trustworthy computing memo and how Microsoft was going to launch this new era of trustworthy computing. How were you a part of that conversation?
That was pretty interesting. There were really two things that went on. Craig Mundy, who was one of the chief technical officers at the time, and Howard Schmidt, the late great Howard Schmidt, who was the chief security officer, were pretty focused on getting Bill to issue something like the Internet tidal wave email. And, so they worked that. And as part of that, there was a big meeting in Building 8 with Bill and folks to talk about security and what things were and what the different aspects of the problem were and so on. And that eventually culminated in the trustworthy computing email, which Bill sent in mid-January. In parallel to that, I had moved with MSRC into the Windows security technology group, the people who wrote the password managers and encryption and access control lists and so on. And I was managing a group that was supposed to deal with what we would now think of as assurance, buffer overruns, code quality, security analysis of designs. And, and how do we get Windows and other Microsoft software better from a resistance to attack perspective? And so my group had an offsite at a little conference center in Bellevue called Robbinswood. And we were talking, the elephant. This was after Code Red. This was after NIMDA. And so we were talking, we've really got a problem. We're not making progress. We're not getting traction. How do we make things better? And Michael Howard had been working with the .NET Common Language Runtime team that was about to release their first version, had a security objective because they wanted to compete with Java. And were finding, just sort of discovering vulnerabilities. And they said, well, what would happen if we stopped all feature development work, took the entire team, focused it on, security assurance, code quality, design analysis, and did that until the bug rate went down. And they were doing that as we had this offsite. And Michael was talking about that. And I said, I wonder if we could do the same thing for Windows, targeting the Windows Server 2000 release that was under development at the time. And I don't know that there was a commitment in that meeting to do that, but there were no better ideas. And so I went back, the offsite ended, I went back to campus. I had a one-on-one meeting with my boss, Doug Bayer, and I said, we think here's something that we've talked about, and we think this might work. And Doug said, that's sort of crazy. It would be big. How would you get people's attention? The developers wouldn't really commit to it. They'd just roll their eyes. And so I talked to the folks on my team. I thought about what we'd do. We put together a plan, put together sort of a sketch of a proposal, went back, talked to Doug again. He had some more questions, maybe a little less skeptical. And he set a meeting with Dave Thompson, who was the vice president he reported to. And meanwhile, we started to talk about what it would take to do this with some of the people in the Windows division. I remember talking to, maybe a little later, to the release program manager for Server 2003. And, I said, we'd like to, stop all development, focus everybody on security. And, sort of you'd like to what? Well, we could probably afford a couple of days. And I said, I was thinking more like a month. And, so we left the conversation there. I talked to Dave. He had more questions, went back, did more homework, more planning. How would we run this? Next meeting was with Brian Valentine, the senior vice president, who was, actually owned Windows Server 2003, and, and his staff. And that was, at no point did I came out of one of those meetings feeling like I'd gotten shot up. And, we just kept, working more details, bringing more people in, figuring out what we were going to do. And then there was a meeting probably in December with Jim Alchin, who was the group vice president responsible for Windows and a lot of other products. And at the end of that meeting, he asked me, okay, so, when do you want to do this? So I can call and preempt the conference center, the big 1,000-person conference room for a week so we can train everybody. And I gave him a date. And the next thing I knew, I had the conference center.
Wow.
And so, okay, so that's the story of the security push. Back to trustworthy computing. All these things were visible inside the company, and all these things were public. Okay. And without the security push, trustworthy computing wouldn't have been viable. It wouldn't have been credible. John Pescatore from Gartner published when the trustworthy computing email came out, published a little note that said, Microsoft has this terrible product security problem, and they've issued a press release. And then people started to say, oh, and by the way, they've taken 8,500 people offline to focus on security. How can that not be serious? And similarly, in terms of the developers and Doug's comment about people rolling their eyes, the Bill email was something that got read internal to the company, and people realized that he doesn't send those often, and he doesn't say that unless if he's kidding. And so that helped us get the credibility and support we needed inside the Windows division to pull the security push off. And so that was really the start of all that change. And you couldn't have had the security push without the TWC email, and you couldn't have had the TWC email without the security push.
It's a really interesting story because you've got the customer-facing crisis, right? You've got the pressure that the whole world was feeling from the vulnerabilities and the exploit and the noise. You've got the leadership support for the culture change. But if it's not backed up by engineering resources and the discipline to make it happen, then it's never going to work. So that, I think, is a really great example of how to execute a culture change successfully.
Yeah, that's right. I talked about meeting with people. We were meeting with and convincing and bringing on board the management of the Windows product division. They ran the security push. We provided the security expertise, but we did it all using the Windows development processes. And we just integrated the things that we wanted done for security into the management and reviews and bug tracking and accountability that Windows already did.
So when you look back on that era and you look at the security development lifecycle that came out of that, what's your takeaway? And what do you think that the SDL's success story really is?
At Microsoft, it was about getting a commitment to security systematized and keeping it intact over a long period. And the other is that, kind of building secure products is, it's an engineering discipline just like anything else. And so what you're trying to do is get a commitment to continuous improvement, to learning from your mistakes, to involvement of building the security as part of building the product, not doing it after the fact. Those are all things. You talk to somebody about how to build high quality automobiles, and they'll say the same sorts of things that I say about the SDL. It's really about getting people committed to doing things the right way, learning from your mistakes, and continuous improvement.
So I remember your retirement party because it was like the who's who of Microsoft security and then some. It was a wonderful day in 2015 when everybody came together. But I just think that it's impossible to call that a retirement party because you've been the busiest retired person that I have ever met. And so you retired and then went on to go become an incredibly busy executive director of SAFECode, in addition to all of your continued work with ISPAB and the national academies and that sort of work. But I want to talk about SAFECode because I think for people that want to learn about software assurance and source code and code integrity, it is the best resource that people aren't using. And so I want to hear more from you about why you're so committed to SAFECode and what people don't know about this small but mighty organization.
So SAFECode came out of the mid 2000s, and it was a collaboration among some vendors that had created processes, essentially emulating the SDL. And we banded together to share information. What do we do? How do we do it? What are the right things to do? What are the wrong things to do? One of the components is how should the government avoid replaying the Orange Book exercise in terms of a lot of expense and not a lot of payoff. And so what we've done, shared the ways we deal with ugly problems, whether it's fuzz testing or whether it's transition to post-quantum encryption or whether it's third-party components, open source, what have you. All those things are topics that SAFECode has focused on. And we, it's sort of at two levels. We do a lot of stuff that we publish to the world that organizations can pick up and use. And then internally, the members are software companies or companies that have a heavy software component to their business, and they meet together. We have a mutual non-disclosure agreement that we can use when something is sensitive, or we don't want to make it public, or we don't want to make it public yet. And so that gives us a forum to just sort of share the challenges, share the problems, share the solutions, share what works, share what doesn't, look for emerging trends. And it's been a very productive and collegial organization over almost 20 years now.
Easy. I remember setting it up.
People can look at the website, safecode.org, and there are resources there that you can just download and look at for free. Or if you're interested in being part of the group that sort of does that and shares information, there's membership information there too.
You said in the SAFECode space that secure development is not enough, which I found sort of shocking coming from the father of the Security Development Lifecycle. But what does that mean?
Particularly with the cloud, where does development stop and administration and operations begin? Supply chain, I mean, people see these numbers, I'm not sure I believe all of them, but it's absolutely true that lots of software organizations are using third-party code, using open source code, dependencies on packages and package managers. It's not only a matter of writing the code that you write securely, but it's figuring out what to do about the code that comes from your partners or people you don't know, and how you get confidence in the security of that. And so, in some sense, there are not any easy answers to any of this stuff, but that's a thing that people have to recognize and deal with. When we created the SDL, we had this term we called giblets, things that are in the package, but that you didn't necessarily responsible for. And, we wanted people to inventory them and have a plan for dealing with the problems in them. And that's the open source problems and the software bill of materials problems and all those things are just the same thing on steroids.
So as you think about how quantum computing, at least the advances in quantum computing are coming faster and faster, and the likelihood of Q-Day coming seems to be more likely, it's possible to think of a time when we could have quantum devices creating code, using AI to create hypercode, at a scale that we just can't comprehend right now. What does that mean, or what does that even look like from a security and assurance perspective?
So this whole matter of quantum computers, Q-Day, what have you, a batch of different issues. When people worry mostly about the development of quantum computers that would threaten the current public key algorithms. NIST has published quantum safe, we hope, algorithms. SAFECode has published our thoughts on how to make the transition to using the quantum safe algorithms. I led a National Academies Committee on the future of encryption back over the pandemic, 2020 to 22, where we talked about, the quantum threat, but also the software engineering and integration threats where, the problem is complexity and software errors can undermine the security, even if you've got the post-quantum algorithms right. And so the complexity of integrating that stuff and plugging it in is not easy. That's all sort of quantum-y related. Then there's the AI in the magic future world where AI is going to write all your software for you, and quantum computers are going to make it faster and more effective at that. And that's really, maybe it's an opportunity and maybe it's sort of a scary thing. There's a paper in the Communications of the Association for Computing Machinery 3 months ago where some researchers did a test. They posed programming problems to GitHub Copilot, write me a piece of code that does this. And then they evaluated that code using one of the static analysis tools and found that it was with security bugs. And so, how do you teach the AI to write secure code? Because left to its own devices and just learning from what's all's on the internet, it's not going to do that.
Yeah, the report said the findings revealed that approximately 40% of the generated code snippets were vulnerable.
Yeah.
So pretty high.
If you look on GitHub, just for people's repositories that they've shared that does the same thing, I don't know how many of them, with that percentage would be above or below 40% vulnerable, but it's a scary number.
So that raises an interesting question, right? You've had a lifetime of work around software assurance. you've talked about the fact that, that A1 perfect state is never going to be possible. So don't even try to climb Mount Software Perfection. But when we're getting to a place where code can be created by machines and imperfect machines can create code imperfectly forever, how do we envision a system that takes the standards and takes the best practices that you've created and then helps make them more a part of the culture? Because that's the harder thing to do.
Well, I mean, part of it's education, which doesn't do a great job of getting people to focus on security today. Part of it is organizations adopting this discipline that we used. This was really created at Microsoft before I got there, but it was refined in the SDL era, called threat modeling, where you try to think, okay, what's the structure and what are the controls, and are there things that you can put in to provide some breaks or some firewalls or some controls that prevent things from going wrong. Part of it is thinking about system management and being conservative. I mean, go back to the days before the Windows security push, and there were just huge numbers of vulnerabilities in the Windows web server. But one of the engineers from, I think it was an office at some point, was a very good, security person. And he demonstrated that if you just took one of these vulnerable web servers and configured it carefully, which was not the default at the time, all the attacks just bounced off. And so part of the lesson learned is to make, to secure by default, which is, the system message. And part of the lesson learned is that, you've got to pay attention, not just plug it in and use it.
So where do you have hope? Do you look at CodeQL and some of the GitHub capabilities? Like, how do you look at the SDL for the AI and cloud era? Like, where are you looking positively at what's coming? Or are you like, I'm so glad I'm retired. Best of luck, you guys.
So a couple things. There's this language called Rust, and it's not perfect, but it keeps you from making the memory safety errors. And if you use it in its safe mode, okay, you can also use it to write memory safety errors just about like everybody else does. But that's a hope, and it's growing in popularity, so that's a good thing. Another thing, this is maybe a little more far-fetched, but another thing I've been looking at a more recent National Academies Committee, apparently the formal verification, the mathematical techniques that we used to think we could use to build A1 systems, the sophistication of those has increased a lot in the last 20 or 30 years. Maybe not to where, people were telling us they were back in 1978, but there's a lot of capability there. And so, again, back to, design and threat modeling and configuration, maybe there's hope that verified components can add some value from a security perspective. And maybe there's even hope that AI and quantum and other things can make those sorts of verification challenges or those verification techniques more usable.
That would be exciting.
Yeah.
So as you think about younger developers, kids that are in school now or that are in grad school, what do you think is the most important thing that they need to learn or go think about as they become the custodians of our future security?
Well, one thing, I remember when I was first running the MSRC, I had a guy that we had hired, this was before we sort of had refined our hiring processes for the Security Response Center. And I brought him a vulnerability report to ask him to, sort of work through it. And he had worked in the support organization previously. And he looked at this thing and he said, it said, you provide this input and this horrible thing happens. And his response to me was, tell them not to do that. Why would anybody do that? Okay, so So one thing, it's good if you realize that if you're a software person, if you're an IT person, your systems will get attacked, and you need to think about that. And then beyond that, if you're a programmer, probably a good idea to learn Rust. If you're a theoretical computer scientist, it'd be great if you'd look at formal verification and think about whether that's something you're interested in and you could work on. If you're going to be a developer or an engineer in an organization that's producing software, look at some of the books about threat modeling. And, because that's an approachable way to figure out what the important things are to do. And then we'll hope that the AI and quantum world will make things better. But meanwhile, don't lose sight of the basics like using a password manager or two-factor authentication.
And the lesson that you talked about early on, always making sure that your systems work for your customers, because if it's not usable,
right? Yes.
They won't use it.
Yes.
So as you look back on your career, what do you think is the most memorable experience, where you had that, wow, I can't believe I'm really doing this, I'm so lucky to be here moment?
Well, I talked about Alchin saying that he was going to preempt the conference center for the security push. And I remember Mike Nash and me briefing Steve Ballmer and his staff on the SDL and what we wanted to do. And, it was like a 45, 50-minute briefing. At the end of that, Steve said, okay, that's approved. We're going to do this. We're not ever going to talk about it again. And I realized that, it was going to be real. It was up to us to make it work, but I thought we could do that. And it turned out we could. And then the last thing was that I think was sort of exciting was much more recently when I saw some of the drafts, I guess I can say that, of the Executive Order 14028, the Cybersecurity Executive Order from 2021, that basically said, okay, if you're going to sell software to the government, to a first approximation, if you're going to sell software to the government, you've got to do something like the SDL. I thought that was pretty cool.
That is pretty cool to see your idea right there in a presidential executive order. Yeah, I'd say that's pretty neat. So this next question, we'll set 14028 aside. If you could rewrite a government law or policy to make a change for the better of security, or if you could write a government policy yourself, what would you want government to do today to improve security? Or if you could do one thing, adopt one standard or one security setting for everybody, what would it be?
Well, for everybody, you come back to the real basics, passwords, 2FA, password managers. For the government, I think they're going in a pretty good direction with the EO, and the EO hasn't been canceled. NIST did a really nice job on the Secure Software Development Framework. There are some technical differences between, what the EO says and what the attestation requirements say and so on. But I still like the recommendation that I put in that paper on software reliability. People ought to just do the entire Secure Software Development Framework, and they ought to show their work. They ought to release their policies that people, developers, vendors, ought to implement the SSDF, and they ought to publish their documentation that says, here's how we're doing that.
That is a very underappreciated point, because there's been some flirtation with software liability over the past, on and off over the years. And I think that the complexity of software, as you pointed out, is such that it's not just about a manufacturer versus, it's not a manufacturer versus customer issue, because secure by design, secure by deployment, secure by, there's so many factors in that space. So as we start to think about wrapping up, where do you think that for companies that are worried about that conversation and that risk of liability, obviously the SDF, the Secure Software Development Framework, is a terrific starting point. What else do you think companies should be thinking about?
From a liability perspective?
If they want to be mindful of those who are looking to increase the liability conversation? What do you do to counteract that?
Well, I mean, I think the big thing internally is to adopt a pretty complete, pretty robust set of practices, including security development, including operational security, including security response, all the things that people do, and then not kid around. Say you're going to do the things that are important and then do them. I think that's the way you get in trouble. I'm not a lawyer, but even absent liability, saying you're going to do stuff and then not doing it is not a good idea.
Indeed. I am a lawyer, and I'm very happy to agree with you on that point. Wow. Steve, this has been amazing, and I could talk to you for hours and do frequently. So I know I'm very lucky in that regard, but I just can't thank you enough, because it's a pretty rare treat to get to go the whole range of the early days of security all the way through to the modern era of quantum, and be able to put so much in context. I mean, thinking about Bell LaPadula, thinking about the Orange Book, the evolution of common criteria, the SDL, the security push, all these practices for companies to take their own software security seriously. It's the evolution of an amazing career. And I'm just lucky to get to have worked with you for the past 20 years. And I'm glad to have you as a friend.
Mostly it's been fun for the last 55 years, and it's been a real treat working with you for the last 20, Cristin.
Oh, well, thank you, Steve. And for everybody, thank you for listening to the Advancing Cyber Podcast Origin Story Series. We hope you enjoy the discussion and that we've advanced cyber along the way. I definitely want to thank our guest, Steve Lipner, and our Advancing Cyber team with management support from D Cyber Communications, our sound engineers, Louis Pelago, and third-year law student Tanner Wilburn, and research intern Layla Moeller. You can share ideas and recommendations at cyber@advancingcyber.com. Security is a community, and we're always look forward to hearing from you. This is your host, Cristin Flynn Goodwin, saying thank you, patch your devices. And as Steve said it too, and I always say it, please turn on MFA. Thanks very much.